Hey everyone, I'm your host Wahid Lutfi. In this video, I'm going to discuss systemd, systemctl, and journalctl. The three of the commands are going to be actually the systemd is the daemons that support systemctl command as well as journalctl. I'm going to discuss all of that one in this video. So let me go through a slideshow here. And the discussion that we're going to do is going to be on Red Hat Enterprise Linux version 9. And we can do it on Ubuntu as well. The distribution, whether it's Red Hat or a Debian distribution of Ubuntu, the commands are very little difference, but in terms of systemctl, journalctl, and systemd, they're all the same, except on the systemctl when you're using like Apache services, for example, the unit name is HTTPD on a Red Hat, whereas on the Ubuntu it is called Apache 2. So that's the only difference. When you install the service and then you start it, stop it, anything you do, you just have to provide the proper unit name. In this case, let's just go start a VM. The VM that we're going to start, let me just go back here. I'm already sharing my screen. I'm gonna just go right here, and then I'm gonna start this VM called algorithm. So I click on the start button, and that would just give me the notification here that says powering VM, and I say that's good. Auto capture keyboard, that's fine. I'm going to just take this notification. I don't need to be notified what is happening. All I need is the system be up and running, which is very fast and efficient. And as you can see, I'm going to log in as Wahid here. After typing my password successfully, I'm going to be provided the interface. And here you can see I'm on the activity. If I click on this, you have all the options, whether you want to open a terminal or check the applications or anything you could do, whether you start Firefox or something. But I'm going to open a terminal here. The default terminal that opens here is this nice interface here, and it shows that I'm logged on as Wahid at localhost. And that also I can just say, what is the OS version Red Hat dash release? You can see it is Red Hat Enterprise Linux 9.1. So as you know that I'm logged on there, let me just check the uptime here. And then that is the system uptime is load average is 0.9, and it has been up. If I run the top command, I can see all the processes are up and running. But at this time, I'm going to be interested in process ID number 1 right here, which is the systemd. So I could also do this one top minus P for process ID 1 and just look at the systemd processes that are there. Right here is the name of the process systemd. The PET process ID number is 1. Because that's the main process that starts the system D as daemon. All the daemons that I can see of, I can do top minus P, and then 1, 2, 3, and so on. All of those ones I can get it that are related to systemd or other processes. The lower the number of the PET, the higher the systemd processes. So number 1 is the systemd, which is the mother of all process in this case. I can also get the top command with minus U for the user, and then I say show me all the root processes. And then you can see that the kernel workers are running, and then the systemd is running, the scheduler, everything, the log writers, everything. All together, you can see the process of them. If I want to just do a PS minus EFA, By default, if you just run ps command, it shows you your current bash in ps, and then echo dollar sign. Dollar sign is pointing to the bash process ID. But if I just say ps-efa grep minus I system D, then I could get all the processes that are related to system D. Let me clear the screen command and just run this command ps-efa grep minus I system D. You can see that I'm seeing all that one. But if I just say, show me only the process ID of the ones that are owned by root, and then the parent process ID, as well as the actual command. So notice that this command is awk column 1, and this is $2, $3. So I can do the same command up here and say awk, and then say print dollar sign. If I just want to say $1 would be the user ID, and then comma $2, and then comma $3. That would be the process ID and the parent process ID, as well as $8. $8 would just give me the actual system process, system D's stuff like that, gnome session and all that. So $8 will be giving me that information. Let me clear, and I don't need to clear the screen, as you can see both of them here, but this is what it is happening here. System D had a parent process ID of 0. And then the actual system D process started with process 1. And then now system D invoked these child processes. One of them is system D dash journal D, which is for log writer and journal stuff, that journalctl command that we are going to look at it next after that one. The other process that is there that is also owned by the parent process ID of it is system D, which is 1. This process is called system udev D, day1, for the udev stuff. And then the log D is another system D process. And then system D, this one is also system D, but it is just doing like Wahid here. So if I just want to grep minus V, my grep, then I should not see that one. So if I just do here and say grep minus V grep, I don't want to display my own grep command. So the grep command is gone now, but system D, this process on the user left system D, I do have a process called this 290. I can also go by ps minus ef a grep minus I 290, and then I'll see that all my session, everything that is maintained, that is that process. So the parent process could be anything else, but then I could also do a sudo on this process here, say sudo lsof minus p, that one, and type in the root password, or my password in this case that I have sudo privilege. Then I can see those processes. So what we wanted to show you is this command here with system D related stuff that are these processes are running. Usually when you run like top minus P, like process 1, this one is the main process that is happening here. So if I just do lsof on that process ID with sudo privilege, say sudo is u dash, I'm going to become root first. Now if I just say top minus P1, this is gonna give me as same thing, but I'm going to do this time lsof minus P1. And you can see all the processes that are being controlled by system D as their parent process, and they are there. And then at the same time, I could do like a pwdx of 1, saying that where it was a spin off. that process, a print working directory of executable, or you could say P3 of one. Process 3, P3 is Solaris command on Linux is process 3. So if I just say process 3, PS stream 3, or process 3, and then I just give 1, it will just show all the processes that are related to process 1. So we did discuss a system D, but before system D was introduced on, we had init. Init was the equivalent to system D. That was the predecessor or system 5 release 4 version of Linux and Unix was using init. Starting at version 6, Red Hat and Linux, they used services. And then on Red Hat 7.6, 7 and up, they used system D. System D was introduced in Red Hat 7 and Ubuntu 16 and so on. All of these versions now, or 95% or 90% of the system that nowadays are on the production environment are using at least Red Hat 7 or Ubuntu or Linux or whatever version they have, they're using mostly system D. Very, very few are still on init stuff, which is the older version. Sun Microsystem, which is running Solaris 11.4, since Solaris 8 or 9, they have been using Service Management Facility. SVC ADM is the command equivalent to System D, and then SVCS is the command equivalent to systemctl command. So you can run those ones, and I have my certification with Solaris 10 with the Solaris 9 back in 2003, and then you can tell how old I have been on these systems and working on them. But let's talk about systemctl here. So systemctl is a very powerful command. You can run a lot of stuff here. Let's say I want to know whether the default systemctl processes. You can just type in systemctl and then pipe more here. You can get all the details of every processes and that are running, every services, every unit that are running. We call it unit or just on the older version, like 6 I mentioned, it was called services, and now it's called service, and now it's called system unit. So you can also do systemctl status and then get the status of every process that are here. If you just follow the option status with a service or a unit name like HTTPD, you can say that, okay, Apache is enabled and it is up and running. So similarly, if I say, and instead of HTTPD, a unit name is SSD, then I can just get this secure shell daemon. Similarly, like if a process like cron D, you can get it. So let's start with one service. I'm going to show you some of the options first before we go on with the rest of them. And then, so the system D has a number of, systemctl has a number of commands that you can pass in as subcommands. So systemctl is for normally the command, and then followed by the action, followed by the name of the unit name and the unit name. So this is like whatever the action is. In this case, like systemctl, the action is the status, and then HTTPD is the service. So the unit name. I could do that one, and if I just have already, I have already installed it, if I just do a DNF install HTTPD, it says the system dependency is already met and you have already installed it. So now if I just say, okay, great, I have already installed it, let's do our pm-qc HTTPD, and it says, okay, yeah, this is the configuration files, and then everything on the etc HTTPD conf file the conf directory is set up and the log is there, so I can get some information there. And if I just run httpd-l, that is the binary that is actually telling me what is, like if I do -v for version or dash uppercase V, give you more details of the modules that it was built or compiled with. So that those are commands that you could do without systemd or Apache, systemctl. If you install it on any Unix machine or Linux machine, you can still use the Apache command line syntax. Like if I want to see if there's any syntax is okay, or if I say config a test, I could do that one, and then Apache CTL config test. And then syntax is okay. I could also do a -t, would also say syntax okay. So some of the parameters that you do, whether you use HTTPD or config test or something, those commands are available. So I could say HTTP status, I could get the status, and if I just say -t, for example, to check for the syntax, or -d for the options, or any option that are here, or systemctl status, sorry, Apache CTL status. Those are options that I could have done within Apache. But now I'm going to show you the same thing with systemctl. So systemctl, and then status will show us the status of Apache HTTPD. And as you can see, it is already, I have enabled it. That means after the system boots, the Apache process automatically starts. And it comes out with a default process ID. In this case is 1037, but next time it may come up with another number or the same number. But these processes that are showing up here are subchild processes of that process main one. So when it says enabled and it's active and running, I can also say systemctl is enabled HTTPD, and it says yes, it is enabled. Or I can say is active, and then it says yes, it is active. Active meaning it's running. So let's just do ps -ef grep -i HTTPD. You can see that the way a systemctl status HTTPD reports, it gives you this process ID 1037, and then at the same time I'm going to do that command ps -efa grep the HTTPD. Notice that the process 1037, that is the main process, is actually systemd is the parent process ID. That's very, very important. And notice that process owner is root, because root start this one, subchild processes, it's coming on the user and group of Apache, which on the httpd.com file, I have already defined what the user should be having access to. And this is the username and group name as that one. So it starts with that as well. And if I just go back to etc httpd, and then conf directory, let me just cd to httpd first, clear screen here, and then run that command here. And notice that I said the main process 1037 started as root, but the subchild process started with Apache. So I could look at this directory here, and there's a conf directory, and then there's a file called httpd.conf file. So grep, let's do a egrep for either user grep egrep -i. I'm going to say either it's user or group, and then inside the file http.conf file. And notice that the username here, this is a directive telling Apache http.conf file what is the account that this process should be on the owner of. And then this is the group was also Apache. And these two user and group is also on your etc password file, grep-i Apache etc password file with no password on the password shadow file, and also on the group file. So you can see that that's why when processes of Apache starts with this, right? Let me just type it in. ps minus efa grep minus I HTTPD, and then grep minus v grep. So you can see when it started, it starts as root first, and then the sub-child processes are there. Why am I showing you that one is very important. So systemctl status HTTPD shows it's up and running, and the main process is 1037. So now notice that if I just do the same command here, I know that there's 1037, and then I could say, okay, systemctl, let's do a reload first. The reload command is telling the operating system, system D, saying that this is the service that I want to start this unit, but I want to reload it just by doing this reload command. Notice that when I do this command, the main process ID is still stayed the same, but these other child processes and that 1037 on them, they just started with a new process ID. So reloads command is different than restart. Reloads reads the configuration files. If there was any changes, it will load it, but it will not stop the main process. Notice now this time I'm gonna just use, instead of reload, a restart. And then the restart succeeded. I do a equal $? You can see it is succeeded as 0, meaning it ran. If I just do the same command that I did here, notice that this 1037, with the restart, it started a new process ID. So every time you do a restart, it just, you get a new process ID. Notice that I did another restart here, I get this main process ID. But if I do a reload, every time I do a reload, actually I did a restart again. So let me just say restart here. I'm going to run the command, and notice that the process ID of it is different. So now if I do another restart, let me just do a first reload. So you can see the 411, 111, it will remain the same. It will remain the same. The reload does not kill the main process, but the restart does it. So when you do a restart, it will just stop everything and start it. And then that one is having a new process ID. So now if I do a stop process, systemctl status HTTPD. Now I'm going to do a systemctl stop HTTPD. And then now since I stopped it, next time I do a status, it just says this is not active, it's not running. As you can see that it is just not running. So if I just run this command, say, okay, it is there, but it is still enabled. So if I reboot my machine, it will be just there. So if I say systemctl is enabled, HTTPD, it says yes, it is enabled. But if I say is active, because I stop it, it says no, it's not active, inactive. Now if I just say systemctl is started, and then at this time, if I say is active, it says yes, active. Is enabled, I think it's enabled. Yeah, it's enabled. And if I just do one more thing here, say, now show me the status, so it's active and enabled, and it will just go back to the same thing. So since it's up and running, I'm going to just go on this other screen here, and I'm gonna say, well, that's good. On this var html, I have a lot of stuff from my development machine that I just mimic the production machine. On the production, if I go here, and this is my website, and that I could just go on, let's say chapter 4, it's this. But if I just go, the reason I'm on chapter 4 here is that this chapter 4, I have done a number of 88 commands, and systemctl and the other ones, systemd right here, systemd is there, systemctl is there. You could actually will practice it online, all of these commands. Like if you want to say, give me the status of Apache CTL, it will just tell you. And if you want to say, give me the version of the Apache, that is, I mean, HTTPD, systemctl dash version of it, or give me help, I'll run those commands for you on my cloud. But if you just say, what about systemd? So on systemd, notice that I could just say, give me status of SSHD on the daemon that is running on the Ubuntu version. But at the same time, I have documentation here that you can come in and read the manual pages for them, and it's all online for you here. At the same time, if you just say, well, I want some PDF documentation, man_PDF as your friend here, that you can just get all the documentation. So you control F here, say systemctl, and then it will come here, and then just read it, the entire documentation online. It is really huge, so you're welcome to just move it slowly, which I'm doing it very fast, because I don't want to take too long for this kind of information, but you can see that you can read it. And then if you are looking for systemd, notice systemd, there's about 186 different commands that are related to systemd. So the systemd is huge. It's not gonna be, if you dedicate the entire course for it, it's not gonna end. That's why we have to just go to some levels of, explaining what we can do and what we cannot. But aside from that one, all this documentation is available. So on the 19, if you click on systemd here, it will just open up the systemd, and it's about 37 pages long with all the nice PDF documentation here discussing the systemd manual pages. So you do have that option as well. But coming back here, since I started systemd on the Apache D, I could say start Firefox here, and then this will open up Firefox. And then if I just go to localhost, since I configured it, notice my localhost is there with the same pages that I have on production. But if I just go here, I also configure it on this server with the name my web uni, and that will just bring it the same thing. If I just show you how I did that one, basically on the configuration files here, clear screen cat etc host, I put this my web uni to be a kind of host name for 127.0.0.1, which is the loopback interface, or the local host information. So if you do fconfig loopback interface, you can see that 127.0.0.1 is there. And then you can do also IPA for address, and you see the loopback interface is the same one. So let's just look at the Apache stuff that we did here. As we did the systemctl, I'm going to show you some of the other configuration with Apache here. So if I just say systemctl stop HTTPD, now I stopped it. Now I refresh this screen, say refresh it, it's not going to come in. And then if I just go back on the screen and then say, okay, that's good. I know that I am on the development machine. Let's start it again. And now I refresh here and web server response. But notice that this is non-secure. So if I just click on any of these pages, I'm going to redirect myself to the actual production environment, which is my webuniversity.com page. And then I get the whole thing here. Yesterday, I also put this, the C and C++ include header files. You're welcome to learn starting, if you're a developer, C programmers, and looking for something like, IO stream, what it is, as a header for C++. This information is going to be very helpful as a student or developer or researchers, for you to just go there and then look at all the C and C++, 2,808 files that are there, all available on this page here. Whatever you want, like if you want to see the standard IO.h C header files, you can see that it's there. And all the functions that are being called inside those ones, it is available here, so you can learn from them. But coming back to localhost, so if I just say HTTP and then go to 127.0.0.1, I get the same page that I get as localhost or my web uni. So whatever I type in, that is on the resolution, it's going to resolve it. Now on the command line here, if I just say, okay, I saw that one, but I want to get a little bit more detail of it. So say systemctl status HTTPD, it shows that it's up and running. This time I'm going to do, instead of a status, I'm going to say cat. And cat is going to basically read the contents of user lib systemd httpd.service, and it's going to show you the actual unit name, the description. All these directives are telling it how to start the service, and what is the name of the service, what is the exact reload, the exact start. Like this exact start is calling httpd to start it with these options with background or the foreground. So the kill signal, all of these variables or directives are defined. This environment variable, like language is equal C, this is the syntax inside systemd. Some of the information that is required, for sure, is service name, that you have to have a service information, and then the unit name, you have the description, and then all the details. Notice that httpd.service, as the documentation says, that means that you have to consult section 8 of the manual pages for HTTPD. So if I go on my website, I can do that one by section 8 will just automatically, if I search for HTTPD, and then just since it's not here, I could just go, let me see, what is this one? Yeah, that's one. So I'm going to go to the command lines and just do that one for you, because that is definitely installed, and it should have the HTTP documentation on the command line. So let me get back here. So it says section 8. There's two ways you can do. You can say man minus S8 and then HTTPD minus S8, meaning that find me the section 8 of the HTTPD. So if I just say man by itself, HTTPD that automatically knows this is section 8. How does it know that it's section 8? If I say where is HTTPD, this file that is there, the gunzip file user share man httpd.8.gunzip. And similarly, look at the SSHD. SSHD is also on section 8. So if I say systemctl status on them, or actually cat SSHD to show me the cat of the contents, notice this man page is also section 8. If another command is somewhere else, then it's going to show you the man pages for that section. Like this one is sshd_config. So if I say man -s5 sshd_config, clear screen. Let me just do this first. So man sshd_config, it should open section 5, and it does. Similarly, if I just put the -s5, it will just do the same thing. Whether you type -s section 5 or not, it finds it, because when you say where is sshd_config, it automatically knows that the manual pages is that sshd_config.5.gunzip. So let's look at a couple of more things on the SSHD. Systemctl cat, we looked at it and we say HTTPD, it shows the content of it. You can also do, instead of cat, you can say edit. So you can see by default it opens nano, and it just gives you these options. But you can say, I don't want nano. You could just say, let's go to lib systemd system, and then since the file, actually there's a file called httpd.service. All the system units that are there, and there's it's by default when it gets installed by the system, it gets installed on lib systemd system. And when you enable it, it creates daemons for it, a service in the var or run systemd system, and then also a lib system D. So and then there's also a directory called etc systemd system. This is also like customization for old legacy that init.d used to use on etc init.d or etc rc 1 through 6, all those ones, the startup script that you could do it by priority number, whether it has a S number for start or a K number with a kill. All those ones were on the old system, but there's a directory here that you could customize this under etc systemd system. As far as the systemctl concern is, you can also do systemctl show HTTPD. Show is going to show the all the parameters that are in the main memory for it, and that is up and running. So you could see that is there. There's a lot of information here that I could cover. If I just don't want to see the nano, I could say export editor is equal vim for vi, or vim for vim. And then now if I say systemctl edit, it is going to use the vim editorial rather than nano. And then I could say, let's say I could say HTTPD. Similarly, if I just now notice that I can do quit here, or say, go ahead, change the color scheme to run. And so I could just have different color scheme here. I could do Control Tab, and then for this one, color Control Tab. All these defaulted stuff that are there, I can see that the options are there. So if I just say to use the slate, for example, it will just do that one. But I didn't like that color, so let me just go another color, say color scheme, and then I say tab, and then if I just want to use the default one, that would be this. So you could have that one for the option that you have here. At the same time, there's the show command I did show you here, show, and then it is not just for one service. You can do for a SSD, and then you could say systemctl cat SSHD, or just cat cron D, or firewall D, whatever command that you do, it is all there. So another option that you can have is on the left system D system. By default, all these ones that are called services are listed here. You can also get the same thing here that are dot service here. You could get it, and then if you want to say show me only the HTTPD, you could do this one, and then you can cat HTTPD dot service is the same thing as systemctl cat HTTPD dot service. So the information that are here, system D give you a lot of stuff. Systemctl system, and then you could say dash list dash unit. Units dash units. Sorry, dash list dash unit. Unit files actually. Let me just see systemctl dash list units. Quickly, I'm going to consult that one. Man system D unit files, and list unit. It's either with dash S, or I mean with S or without this. So if I say unit files, unit, okay, the argument that you can see that there's so many of them. If you didn't type it for a while, nobody memorized it by exact characters, and then that's why I missed it. So let me just find I might just say list a unit. Okay, clear screen systemctl dash list unit files, unit file. System D list. Yeah, list dash units. So it is part of a systemctl dash. There's no dash. That's what I was typing. Units, and then so systemctl list units. That would just give you all the units here, and then you could just say, give me units dash files dash file, or maybe units is good enough. You could get all of it, and then you could just say units dash type is equal service. So you can just list all the services, and then you can see the description is saying that load and everything. Here you could get that, and then the type you could say and show me all the socket by the sockets there, or show me all the one that are target. And then if I just go with a target, let's do this one and say start.target. And then you can see all the targets, whether it's the system default ones that are you set up with multi-user, or power off, or graphical, or whatever RAM level that you have, those are the targets. So another command is say systemctl get dash default. get dash default will show you the target level. So right now it's a graphical, and then you can see that graphical.target is there. And if I say change it to multi-level, notice that multi-user.target is another one, but the graphic is because we're on the GUI, we can set it back. I'm gonna just say systemctl and then say set dash default, and then just say multi-user.target. So that would just change it. Notice earlier I was telling you that directory path. Here it helps you that where did I just create the symbolic link for this one. So if I just do get that default one again, it says now it's set back to multi. But I want to just go back to the target with graphical dot target where it was here. So you can set it like that, and then now the symbolic link is created, and then clearing the screen again, running the get dash default, it will say we're set to target. Also, there's systemctl daemon reload, that if you want to reload it, you can reload it as well. Daemon dash reload, whenever you make updates on the editing the units, you need to do a default dash reload. Daemon dash reload. So the other thing that I want to show you here is that systemctl disable. First, let's stop HTTPD, and then now this screen should just refresh to saying it is down, and then I'm gonna just say, okay, great, I did it, stop it, and I'm gonna also turn it off. For example, let's say I go back here, and we did a stop. This time I'm gonna say disable. Notice that the symlink was removed from this one. But now if I just say systemctl status HTTPD, it says that it's disabled. So that means it doesn't start at boot time and it is not active. But notice as soon as I enable it back with the enable option, then it's going to show me where it created a symbolic link for it, the path to it, and then at the same time, now if I just get another status, it says that it's enabled, but it is not running. So in order to run it again, I have to do a start here. And now the next time the system boots, because it's enabled, it will come back again. And if I refresh this one, it should go back to normal and saying that it's up and running. So we showed you those ones. While it is running, I want to show you a few commands with journalctl, and then we end this video. So on the journalctl command is basically systemd. It uses that one for logging purpose. And then on the old system, we had var log messages and var log syslog and var log or syslog. So those ones are still there. And what you need to do is just say journalctl-xe if let me just type it correctly, journalctl-xe. This will just show you all the extended logs of everything that is happening. If I want to get the like dash xl, and then you can see that it's all the information since the last boot or just here. So this is a lot of information. I don't want to go through them, but at the same time, you can say journalctl and dash L, and then just say dash U, the unit name. In this case, I want to see HTTPD. So all the HTTPD daemon logs are going to be there, as well as you can say dash F for just tail minus F kind of syntax. It will just set there and it will read whatever a new update comes in on the Apache logs there. Also, on the command lines, you can go to HTTPD and there's logs here. Inside the logs directory, you have some files here, access.log and error.log. So if I just access it and there's no error, it should be written to access.log here. So notice that I'm going to just press here and just show you and that I'm going to go to the page and then I say, okay, open up index_n.html. And as soon as I do that one, notice my access log already has this entry saying that, okay, I just referenced that one. And you can see that index_n is showing that I was looking at it. If I go here and say, just open the index.html, then I go back to my access.log file and look at that again. Notice it is right there. So it tells me that I just accessed index.html and what poured all that information. So I hope you enjoyed this one. And then we discussed systemd, systemctl, and journalctl. Sorry, I was a little bit fast on the discussion, but you can watch these videos, pause it, or the area that you need to understand the most, you can just pause it and just understand it. And if you have any question or comments, please make the comments so I can improve it based on your needs. Thank you for watching. Thanks for your time. God bless you all. Take care. Bye-bye.